The next test for series divergence that we're going to learn is the direct comparison test. The direct comparison test really stems from one big idea. If we are adding up positive terms, there's really only two ways that a series can behave. It could be that the sum is diverging to infinity, or it could be that the sum, as we add more and more terms, gets closer and closer to some finite number. The intuition is if our terms being added are too big, the series will diverge to infinity, but if they're small enough, the series can converge to a finite number. I thought it was about time for a new visual analogy, so in this video we're going to be stacking up hippos. Just like we were stacking up rectangles before, the height of each hippo is the term of the sequence being added. So if I stack them all up, the combined height of the stack is the sum of the series. This series looks like it's convergent. It looks like as I add more hippos, my stack is getting closer and closer to some finite number. So I think of these terms, these things being added, as being small enough that the series can converge. On the other hand, here's another series. The terms are getting smaller and smaller. They're going to zero, but they're bigger than the terms we saw before. The first one's the same size, but then after that, my terms are bigger. So I think of these terms as so big that the series diverges. This brings us to the direct comparison test. We're comparing two series. The B series is a series whose behavior, whether it converges or diverges, is known. The A series is a series whose behavior, whether it converges or diverges, is unknown. For this to work, we need to be adding up positive numbers. Let's start by looking at the first bullet point. Here's a series whose behavior is known. It's a P series with P equals to 2, so it converges. Here's a sequence with smaller terms. If I let an be the sequence 1 over n squared plus n, and I let bn be the sequence 1 over n squared, then let's look at the comparison test. They both have positive terms. My an's are smaller than my bn's, and my bn's converge. So the comparison test tells me that when I add up my a sub n's, that series converges as well. And the reason for this is exactly this intuition that we talked about at the start of the video. The fact that this series converges means the terms being added are small enough. When we consider the other series, these terms are even smaller. Now remember, when I'm adding up positive terms, there's only two things that can happen to the series. It can converge to a finite number, or it can diverge to infinity. The terms on the left are not big enough to make the sum go to infinity, so certainly the terms on the right are also not big enough to make the sum go to infinity, because those terms are even smaller. That's why we can conclude that this mystery series converges as well. Now let's look at an example of the second bullet point in the direct comparison test. This is the harmonic series. It's a P series with P equal to 1, and that's a divergent series. Here's the terms of a different sequence, and these terms are larger. So we let an be the terms of our new mystery sequence, and we let bn be the terms of the harmonic series. And now let's check out the comparison test. Both of our series have positive terms. The an's are bigger than the bn's. They have a smaller denominator. And when I add up my bn's, that sum diverges to infinity. So the direct comparison tells us that our mystery series diverges too. And remember, we're not too concerned about where it starts. The fact that it's an infinite series is all that matters. One or two terms at the beginning isn't going to impact whether this converges or diverges. Again, let's see how this relates to this intuition from the top of the video. The harmonic series diverges, so we think of its terms as being quite big. They're so big that when I stack one on top of the other, this stack increases to infinity. My mystery series has terms that are even bigger. So if the first stack goes up to infinity and the second stack is made up of bigger terms, then certainly if I were to keep adding terms on the right, they would stretch up to infinity as well. That's why the direct comparison test tells us that this mystery series diverges as well.